same salt you sprinkle on your fries could one day power your home, your car, and even entire cities. Imagine a world where energy storage isn't limited by rare, hard-to-mine metals, but instead relies on something as simple and abundant as sodium chloride. That world is closer than you think. As renewable energy adoption surges, the need for affordable, scalable battery solutions has never been greater. Lithium, the current king of energy storage, is running into real limits, supply bottlenecks, environmental costs, and high prices. Enter sodium-ion batteries, built using salt-based chemistry, offering a sustainable, cost-effective alternative. Researchers have been working for years to crack the code, and now, breakthroughs are turning science into scalable reality. From electric cargo trucks to home energy systems, sodium could be the game changer we need. But how did something so ordinary become so revolutionary? Let's break it down. Lithium-ion batteries, while powerful, come with growing concerns. A recent report found that lithium extraction requires up to 500,000 liters of water per ton, straining resources in arid regions like the Atacama Desert. Environmental damage is compounded by the fact that lithium reserves are unevenly distributed, with over 50% concentrated in just 3 countries. This scarcity drives up costs and limits scalability. Consider sodium-ion batteries, a promising alternative using an element far more abundant than lithium. Sodium, a key component of table salt, is found in seawater at concentrations over 100 times greater than lithium in the Earth's crust. Researchers say sodium-ion batteries could soon power budget electric vehicles, cargo lorries, and even home energy storage systems. With production costs significantly lower and no need for rare minerals, these batteries offer a more sustainable path forward. As the demand for renewable storage grows, the limitations of lithium become harder to ignore. The shift may be closer than we think. Sodium and lithium share a unique chemical kinship, sitting in the same column of the periodic table. This means they both have a single electron in their outer shell, making them highly reactive and suitable for energy storage. Researchers say sodium-ion batteries could become a sustainable alternative, especially as lithium resources grow scarcer. A recent report found that while lithium-ion batteries still lead in energy density, sodium's abundance and lower cost make it ideal for budget electric vehicles and grid storage. Take sea salt, for example. A 2021 review highlighted how sodium extracted from seawater could power the next generation of batteries without the environmental toll of lithium mining. Consider China's recent 1 GWh molten salt battery project, which shows how sodium-based systems are already being deployed at scale. With these advantages, sodium is not just a backup plan, it's a promising frontrunner. And as we'll see next, its performance in extreme conditions could be game-changing. In university labs and research centers, scientists are fine-tuning sodium-ion batteries to match the performance of their lithium counterparts. A recent report found that sodium's abundance and low cost make it ideal for budget electric vehicles, heavy cargo transport, and home energy storage systems. Unlike lithium, which requires mining from limited global sources, sodium is readily available in seawater. Researchers in China have already developed prototypes using sea salt as a raw material. One lab at a leading European university has achieved an energy density of over 160 Wh/kg, closing the gap with lithium-ion. These batteries also perform better in extreme temperatures, making them suitable for regions with harsh climates. Consider the 1 GWh molten salt battery project launched in the world's leading wind power nation. This showcases how sodium-based technologies are moving from theory to real-world application. As lab breakthroughs continue, the next step is scaling up production. That transition will be the focus of the next scene. The Earth's oceans hold an almost limitless supply of sodium. Every liter of seawater contains about 10.8 grams of it. With 361 million cubic kilometers of salt water, covering 71% of the planet, sodium is essentially everywhere. Unlike lithium, which is concentrated in a few regions like the Lithium Triangle, across Chile, Argentina, and Bolivia, sodium's ubiquity removes geopolitical bottlenecks in supply chains. Researchers at the University of Texas recently demonstrated a sodium-ion battery prototype made from sea salt, proving the material's viability at scale. China, the world's largest producer of sodium-ion batteries, plans to deploy them in everything from low-cost electric buses to home energy systems. This shift isn't just about availability, it's about economics. Sodium-ion production costs are up to 30% lower than lithium-ion, according to a 2023 study in Materials for Renewable and Sustainable Energy. As demand for energy storage surges, sodium's abundance could become its greatest advantage. But how does it stack up in performance? That's what the next breakthroughs will reveal. Sodium-ion batteries are emerging as a compelling alternative to lithium-ion, especially when it comes to cost. A recent report found that sodium is over 1,000 times more abundant in Earth's crust than lithium, drastically reducing raw material costs. In fact, researchers say sodium-ion production can be up to 40% cheaper than lithium-ion, thanks to the availability and low price of sodium compounds like table salt. Consider the automotive industry. While luxury electric vehicles may stick with lithium for higher energy density, budget EVs and commercial vehicles could shift to sodium, slashing manufacturing expenses. Take cargo lorries and grid storage systems, where cost efficiency matters more than peak performance. China has already begun deploying sodium-ion batteries in home energy storage, leveraging their affordability. With production scaling, these batteries could redefine energy storage economics. As we look ahead, the next scene explores how sodium-ion tech performs in extreme climates. In extreme climates, sodium-ion batteries are showing a performance edge over their lithium counterparts. A recent report found that sodium-ion batteries maintain stability in temperatures as low as 20 degrees C and as high as 60 degrees C, making them ideal for regions with harsh weather conditions. Unlike lithium-ion batteries, which can degrade rapidly in extreme heat or cold, sodium-ion variants retain up to 90% of their capacity in sub-zero environments. Consider the case of a 1 GWh large-scale molten salt battery project launched in the world's leading wind power nation. This initiative highlights the growing reliance on sodium-based technologies for consistent energy delivery. Researchers say sodium's abundance and low cost also mean these batteries can be deployed more widely, especially in off-grid or remote locations. With lithium resources dwindling and extraction becoming increasingly controversial, sodium-ion batteries offer a resilient, scalable alternative. This adaptability positions them as a key player in the renewable energy storage revolution. As we look ahead, the next challenge lies in optimizing their energy density for broader applications. Molten salt batteries are emerging as a game changer in renewable energy storage. Unlike traditional lithium-ion systems, these batteries use salts, like sodium chloride, the very compound in your kitchen table salt, to store and release energy. A recent report found that sodium-ion batteries could replace lithium in grid storage, especially where cost and resource availability are key. Take China, for example. The world's leading wind power nation recently launched a 1 GWh molten salt battery project to stabilize its renewable energy grid. Sodium is abundant, cheaper, and easier to source than lithium, making it ideal for applications like home energy systems and heavy-duty vehicles. Researchers say sodium-ion technology could dominate budget electric vehicles and storage in extreme climates where lithium performance drops. With energy demand rising, the shift from lithium to salt-based solutions is accelerating. This transition isn't just about cost, it's about sustainability and scalability. As we look ahead, the next frontier is scaling these systems for global impact. In 2023, BYD unveiled a sodium-ion battery with an energy density of 160 watt-hours per kilogram, a figure that positions it as a serious contender in the budget electric vehicle market. This breakthrough is especially impactful in regions like China, where sodium's abundance and low cost make it a strategic choice for scaling renewable energy storage. Unlike lithium, which requires complex and environmentally taxing mining processes, sodium is readily available in seawater and common salt deposits. A recent report from the International Energy Agency highlights that sodium-ion batteries could reduce production costs by up to 30% compared to lithium-ion, making them ideal for home storage systems and commercial applications. As BYD integrates this technology into its electric buses and grid solutions, it's not just a scientific curiosity, it's a scalable reality. With over 1 billion people in China alone, the potential for widespread adoption is immense. This shift marks more than an energy transition, it's a redefinition of what's possible. Tesla, long a pioneer in lithium-ion battery tech, may soon turn to an unexpected ally: sodium. Researchers at the University of Texas at Austin suggest that while high-end electric vehicles will likely stick with lithium, budget EVs, cargo trucks, and especially grid storage systems could benefit from sodium-ion alternatives. A recent report from Science Direct highlights that sodium is not only abundant, but also far cheaper to extract, with production costs estimated to be 30 to 40% lower than lithium. Consider China, where a 1 GWh molten salt battery project is already under construction, signaling a shift toward scalable, low-cost storage. Sodium-ion batteries, derived from the same element as table salt, offer a sustainable path forward. With Tesla's gigafactories pushing for more affordable and eco-conscious energy solutions, sodium could soon power not just homes, but the future of renewable energy storage. As the grid evolves, so too might the chemistry behind it. Sodium-ion batteries are emerging as a greener alternative to their lithium counterparts, offering a sustainable path forward for energy storage. A recent report highlights how sodium's abundance, found in everything from kitchen salt to seawater, reduces the need for environmentally costly lithium mining. Unlike lithium, which requires extensive and often ecologically damaging extraction processes, sodium is readily available and far cheaper to source. Consider China, where researchers are already developing sodium-ion batteries from sea salt, aiming to replace lithium in grid storage and electric cargo vehicles. These batteries may not yet match lithium's energy density, but they shine in cost efficiency and scalability. With over 1 gigawatt-hour of molten salt battery projects already deployed in wind energy systems, the shift towards sodium is gaining momentum. As the world seeks cleaner, more accessible energy solutions, sodium-ion batteries could become the unsung hero of the renewable revolution. Their rise marks a pivotal step toward a more sustainable energy future. Despite their promise, sodium-ion batteries still face hurdles in energy density and performance. A recent report found that while lithium-ion batteries typically offer energy densities of 150 to 250 watt-hours per kilogram, sodium-ion variants currently lag behind at around 100 to 150 watt-hours per kilogram. This gap limits their use in high-performance applications like long-range electric vehicles. Researchers say this is due to sodium ions being larger and heavier than lithium ions, making them less efficient at moving through battery materials. Take the case of cargo lorries and grid storage. Here, sodium-ion batteries could shine, thanks to their lower cost and abundance. A study in materials for renewable and sustainable energy highlights sodium's economic advantage, noting it's over 1,000 times more abundant than lithium. Yet, until performance catches up, sodium will likely remain a complementary player. As the technology matures, it may bridge the gap between affordability and capability, ushering in a new era for sustainable energy storage. With lithium resources stretched thin and extraction practices under scrutiny, sodium-ion batteries are stepping into the spotlight. A recent report found that while lithium-ion will likely remain the standard for high-performance electric vehicles, sodium-ion could become the go-to for budget EVs, heavy-duty cargo vehicles, and home energy systems. Consider China, where researchers have already developed sodium-ion batteries using sea salt, leveraging sodium's abundance and low cost. This shift isn't just theoretical, pilot projects are already underway. One striking case is a 1 GWh molten salt battery project in the world's leading wind power nation, demonstrating real-world scalability. As material science advances, we're seeing improvements in energy density and cycle life, bringing sodium-ion closer to commercial viability. The road ahead includes refining manufacturing processes and securing partnerships with automakers and energy providers. With these steps, sodium-ion batteries could soon become a cornerstone of a more sustainable energy future. Salt, the very ingredient we use to season our food, is now at the heart of a quiet revolution in energy storage. A recent report found that sodium-ion batteries could dominate budget electric vehicles, cargo lorries, and even home energy systems, thanks to their lower cost and abundance. Unlike lithium, which requires energy-intensive mining and processing, sodium is everywhere, literally. A case in point, researchers have even developed prototypes using sea salt, tapping into an almost limitless supply. Take China, where a 1 GWh molten salt battery project is already in the works, demonstrating the real-world potential of these technologies. With the global push for renewable energy, sodium-ion batteries offer a sustainable path forward. So, what's next for this kitchen-to-grid transformation? Let us know your thoughts in the comments, and be sure to check the description for sources and links to explore more.